As we can see here, line BC is congruent to line CD because that is given. Line AC bisects angle BCD, and that is also given. And since it bisects, that proves up here that angle 1 and angle 2 are congruent. They'll split directly in half. And then we can say line AC is congruent to line AC due to the reflexive property. And then after that, we can say that triangle ABC is congruent to triangle ADC due to the side angle side postulate. And then finally, ABCD is a kite due to the definition of a kite, which is that a kite is like a triangle being reflected over diagonal, which it has. And that diagonal in this kite is AC. And that's it.
So here you have number 5, which is a proof asking to prove that quadrilateral EFG within ABCD is a rhombus, given that EFGH are all midpoints of their sides. First thing you can say is line BA is equal to CD because of the properties of an isosceles trapezoid. Then you can say BE, CG, EA, and GD are all equal because they are all equal to half the value of their sides because they are split up by the midpoints. You can then do the same thing for AH, DH, BF, and CF. And then using that, you can find that triangles EAH and GDH, as well as FEB and FGC, are all equal. The hypotenuse of the triangles are equal because the other two lines are equal, meaning the third one would have to be equal, which is the side-side-side postulate. And you can say that line EF and GF are equal because of the earlier proof that those triangles are equal. And then you can say the same thing with EH and GH because EAH and GDH are all equal triangles. You can then say triangle EF and EH are the same distance from point E as, you can say that point F is the same distance from E as H because they're both the same distance from the midpoint of the equal sides. Then you can say the same thing for GF and GH. And using this, you can prove that quadrilateral EFGH is a rhombus because all sides of the shape are equal, and there are two sets of parallel sides on the shape.
5, 4, 3, 2, go.
Alright, so I'll be proving that lines TH and AP are congruent within this rhombus. To start off with our given statements, TH is parallel to AP, TO is congruent to SP, and they're also parallel. And then I did TS is congruent to OP, and it is also parallel because the rule of the rhombus, its opposite sides will be congruent and parallel. So we have those. Next, since I'm going to make triangles, I said SO was congruent to SO for the reflexive property. And now we have three sides that make a triangle. So using SSS, triangle SOP is congruent to triangle OST. And then using CPCTC, we can do angle THO, which is right here, and angle SAP, which is right here, are congruent. And we can also say that angles POS, which is right here, and angles TSO, which is right here, are congruent. And that allows us to do angle side angle for triangle THO and PAS. And since we have those triangles and we know they are congruent, since AP and TH are lines within those triangles, we can say that TH is congruent to AP using CPCTC.